Hello everybody and welcome back to question number 10 on the 2008 MMC. So we're at the very end of our very first Manitoba paper, but it will not be our last. So question 10. In the diagram, triangle ABC is isosceles with AB equal AC. Prove that if LP equals PM, so P is some point here on BC, then LB is equal to CM. And I don't know if it's weird that they gave us this diagram here because it really tells us sort of how we should be doing it. And this picture would have sufficed. Could have said, let P be on BC such that LP equals PM, prove that LB is equal to CM. Regardless, it's nothing to worry about. So let's use the diagram that they gave us. So it's got this extra little point D here. So first we're going to make our isosceles triangle. And we extend it a bit, apparently, to M. We got this point P here, and we've got L, C, and A, and B. Okay. So, let's pretend that we were creating this diagram for the first time. So, AB is equal to AC. So, angle ABC is equal to angle ACB. I'm going to label them in green. So, these two green angles are the same. Alright, so let D be on BC so that LD lies parallel to AC. So I'll put this D here. Now, since it lies parallel, since LD is parallel to AC, angle LD, they both must hit the line BC at the same angle. So LDB is equal to ACB, and that's our green angle again. So triangle LBD is isosceles, because we got the same angle here. So it's isosceles with LB equal to LD. And I want to show that LB is equal to CM, so I'm slowly moving this this length over. And so what else can we say? Well, I think they had it labeled, although it's kind of clear as well that these two angles are equal. So being opposite in an intersection of two lines, we see that angle LPD is equal to angle MPC. Okay, and since LD is parallel to AM, LM is transverse to this, so it goes across them. It's transversal. We see that angle PLD is equal to angle PMC. So we'll label that with purple. So these angles are equal. And we also know so if those angles are equal, then the remaining angle, then LDP must be equal to angle MCP. And we'll label that with orange. So triangle LPD is similar to triangle MPC, we're going to show that it's congruent. But LP is equal to PM, so LPD is actually congruent because they have a common side length. Well, not a common side length, but the same side length in the same position. So they're similar with a common ratio of 1. So MPC. Therefore, LD is equal to MC. But then LB, the thing we wanted, was equal to LD, which is now equal to MC. And that does the proof. That finishes it off. Okay, I wonder how much harder this would have been if they hadn't given us the diagram right here with the hints. I mean, they even have LPD and MPC labeled as being equal. But, you know, they gave it to us. This isn't from the solutions. This is the actual paper. You know, no other solutions anywhere. So I have to imagine the diagram was part of the question. Maybe they thought it was too hard to do without the diagram. But there it is. So that did not take me that long. I mean, going back to comparing with the Euclid again, question 10 on the Euclid takes me forever. This one, not that bad at all. This is a nice light contest, but still gets our proof skills going. Still aimed at those grade 12 students who have nothing to do at the PCF on the day of the PCF and who are looking to prepare for the Euclid. This is a great contest to prep for that. I wonder if Manitoba offers scholarships based on performance on this one, or if this is meant to be prep for the Euclid, or if this is just more fun. I don't know. I certainly had fun. What did you guys think? If you want to, leave a comment, like, subscribe, those sorts of things. Let me know whether or not you like doing these other types of contests. And, yeah. So it'll be the 2009 MMC coming up next. And, yeah, that's all I've got to say. Have yourselves a wonderful day, and as always, thanks for watching.